Take our quick look at the calendar here. So today is class number 6. We start on page 34. We are talking about equations of lines. What happens next class? Quests. So our very first in-class assessment, quest number 1. It is on material from classes 1 through 5, which is everything that we did up until Friday, but not counting the stuff that we're going to do today. So our quest is next class, but it's not on the material we covered today. In terms of studying for the quest, I will point out a couple of things. Number 1, if you go a few pages down the road in the packet, I guess this starts on page 40. If you jump to page 40 real quick, you will find some practice problems for quest number 1. There they are. I think this is a really good resource. You will find an answer key a few pages away at the end of the practice problems. I will also point out that if you go onto Moodle, here's our page, and you take a look down here, there's a section I've called Sample Quest and Test Materials. The Word document is just a clean version of the thing you have in your packet. If you do them in the packet, but you mess something up and you want to reprint just the quest problems, you can do that. If you come down here to the PDF of quest number 1, this is my full color solutions written out, not just an answer key, but actually how I solve the problem step by step in color. That's there. And then finally here, you see a link to the playlist for sample quest 1. I made videos of me going through each of the problems on the sample quest. So even though we don't have like a review day like set aside for the quest, essentially you have all the problems done as if I were there doing it in front of you. And you can take a look at any of the problems in that playlist. Any questions about the resources for the quest? Okay. Then let's get started back here again on page 34. And we'll go up here to the top. Mariah, number 1.
Today we will discuss 2 ways to represent the equation of a line. Slope-intercept form. We'll also use slope-intercept form to sketch a graph of the line.
Thank you. Let's move on to number 2. We're going to sketch the line that has a slope of m equals -2/5 and a y-intercept of 0, 3. So first thing I want to do, this little quick check. The slope is -2/5. Now most of you have already done that GeoGebra assignment, and hopefully you wrote down some conclusions like the following. If the slope is a really big number, then the line is really steep. And if the slope is a number close to 0, the line is fairly flat, fairly horizontal. But there's something else that maybe some of you wrote, and that had to do with whether you had a positive slope or a negative slope. So positive slopes and negative slopes just give you 2 different kinds of lines, one of them increasing and the other one decreasing. So what can you tell me about the slope of this first line on the left here? This is a negative slope. And you know right away it's going to be negative because it is going downhill. It's decreasing. And remember we talked on the very first class, decreasing means you're walking left to right and you're going downhill. We always walk left to right. And so I guess that means that this one over here must have a positive slope. And so our little check here says that the slope in this example, -2/5, is a negative number. So what can we say about what the line is going to be doing? It's going to be decreasing. Okay, so let's sketch this line. We wanted to have a slope of -2/5 and a y-intercept of 0, 3. So the first thing we're going to do is plot this point 0, 3 right there. Now we don't have a second point to plot. What we do have is the slope. It's -2/5. Turns out that's enough for us to get a second point and a third point if we want. So I'm going to do this in 2 ways. So that -2/5, you guys know, is the same as a -2 on top divided by 5, yes? Right, we know that a negative in front of a fraction, you could put it upstairs. We could just as well put it downstairs. So I could have said -2/5 is really 2 over -5. And one last piece to this puzzle, and then we'll find our other point. Remember that the slope is the change in something over to change in something. Which letter goes on top? Always? It's always y on top. Good. So putting this all together, we can say that that -2 right over here is a change in y, which means it's either up or down. And because it's -2, what does that mean? It means it's down. So that number right up there is saying go down 2. And then this 5 is the change in x, and it's positive. So of left and right, which one says positive in the x is to the right. So this one says go right 5. And these are the directions. We're just like following a map here. It says take 2 steps down and 5 steps to the right. Lauren?
Would it work if you did like class 5?
We will. That'll be the second way that we do it. That's a good question. Okay, so let's go from our original point. We're going to go down 2 and right 5. So we go down 1, 2, and then right 5. 1, 2, 3, 4, 5. And that puts us right there. Down 2, right 5. And that's enough. You can draw the line right now by just connecting the dots. But let's go ahead and do this one more time. So go another 2 down and another 5 to the right, and you'll land on another point. 1, 2, and then 1, 2, 3, 4, 5, and we get there. But just as well, we could have been thinking of this -2/5 slope as being written in this form, a 2 over -5. That 2, again, is a change in y. So up or down, what does that 2 say? Yeah, that 2 says go up 2 because it's positive. So go 2 up. And then -5 in the x direction says go left. And so this is exactly what Lauren wanted to do. And it's equivalent, right? Just go up 2 and left 5. So how about I go from the starting point, this purple one, we'll go up 2 and then left 5. 1, 2, 3, 4, 5. And we land right there. And that's plenty. All we need is 2 points. So just connect the dots with a straight line. And that's it. Questions on that? Okay, so let's move on to number 3, which is something that I expect many of you have seen before. Boo? Okay, so this y equals mx plus b, many of you have already seen, and you know that m is the slope and b is the y-intercept. So if it happens that, that you have the slope and the y-intercept given to you, like we did in this first problem, then it's really easy to write the equation of the line. So using the information that's up there, we'll copy our new equation for the line, y equals mx plus b. All we have to do is fill in the blanks. So let's see, y equals, what's the slope for this line? -2/5, that's the m. And then we copy the x, and then plus, the b is the y-intercept, or more specifically, the y-coordinate of the y-intercept, which is what number in this problem? It's 3. So that right there is the equation of the line that we graphed. And if you went on GeoGebra and you typed into that little input bar, y equals -2/5 x plus 3, it would graph exactly the line that we just did. Questions on where the numbers came from? Okay, so other info that we can get from the equation of a line. Number 4, in each of the following, identify the slope and the y-intercept. Okay, so the first one, y equals 5x plus 4. What number is the slope? It's 5. The slope is just the number touching the x. So we just grab it. It's as easy as that. 5. The value of b, again, b is this guy that's sitting here at the end. In this case, it's 4. And if I wanted to write the coordinates of the y-intercept, it's got two numbers, 0 and then 4. The y-intercept is always 0 something. In this case, it's a 4 because that's the last number we see in the equation. Okay, part B is a tiny bit more work. It was easy to see that the slope was 5 in the previous one because you just grab the number touching the x. Unfortunately, the number touching the x is, well, it's not really written out in front of the x. It's kind of part of the x. So we need to rewrite that. You guys buy this? Negative 1/3 x is the same as negative x over 3. The division by 3 is on the bottom. If you really want to see the details, write the x as x over 1. And then multiply them together, and hopefully you see you get negative x over 3. So now that it's written as negative 1/3 x, what's the slope? This is negative 1/3, just the number touching the x. Okay, and the b is 5, which means the coordinates of the y-intercept, 0, 5. Why is part C harder? It's in standard form. It's not in this slope-intercept form. If it looks like y equals mx plus b, that information is just sitting there ready for you to grab. But here it's not in mx plus b form. In order to get it in mx plus b form, we need to solve for a certain letter. What letter is by itself? Is the y. So we need to solve that equation for y. So let's solve this equation for y. First, we'll take the 4x, move it to the other side by subtracting. And then to solve for y, what do we need to do? Divide by 3. Okay, so we solved for y. Unfortunately, there's still more work for us to do, because even though the y is by itself, it doesn't look like y equals mx plus b. In order to make it look like this, we're not allowed to have one big fraction. I can't just have everything divided by 3 because it's not in that form, the mx plus b form. So what we need to do is somehow handle the fact that that 3 is underneath everything. So let me ask you a question. 1/7 plus 2/7, what does that equal to? It's 3/7, right? But I'm going to write it this way. Agree? It's 3/7, yes? Okay, so apparently, if I have something like this, where there's the sum of two things on top of a single number, then I get to break this guy up into two fractions, plus sign in between, and that 7 ends up getting written twice, yes? So if you have the one fraction in this form on the right, you can split it up into two fractions. That 7 right down here is really under the 1 and under the 2. Now we hardly ever go the other direction, but this is a case where we need to go the other direction. So that 3 is underneath both terms up on top. Yeah, I'm going to take an extra step from what Brittany is suggesting. I'm just going to write it out like this first, and then we can clean it up. But do we see it's the same thing? That 3 is underneath both of the terms, so we put it underneath both terms. So it's so the 3, you have to divide both sides by 3 because there's a 3 you're trying to get rid of. So it's very naturally underneath everything. But I have to do something unnatural to get it to look like mx plus b. And so what we'll do is take that, it's like the 7 that's underneath, you know, this one fraction, it actually ends up being underneath two different fractions. Mm-hmm. Mm-hmm. Yeah, so if you had something like 8y equals 10, and you divide both sides, it's just something like that. Maybe that's what you're used to. But if this guy here was really a 10 minus x, you can't just divide the 10 by the 8. You got to divide everything by the 8. Yeah, whatever you do to one side, you have to do the entire other side. Unfortunately, that makes things more complicated in this case. Okay, almost done. This is equal to, let's see, 12 over 3 is 4, minus. Now, the last piece to this puzzle is that I really want to be able to write some number times x. So can you guys peel off the number that's, what number is touching the x? It's 4/3. It's the entire fraction. And so that idea of peeling off whatever number is touching the x, if it feels fast to you, that's okay. Take your time and verify later on that you believe that 4/3 x that we just wrote is the same as the 4x over 3 that was up above. And now once it's written in this form, it's really easy to get our information. Remember, m is always the number touching the x. What number is that? It's negative 4/3. 4/3 is there. That negative sign is part of it too. And the value of b is the number sitting by itself. Positive 4 in this case. So these are the things that we'll put in the blanks up above. Yes? Yes. So Alan wants to know if we could write it that way. Absolutely. I came from which equation? I guess I just started with this equation and I subtracted 4x, and so for me, naturally, that minus 4x was at the end. Alan has a really good reason for wanting to put the negative 4x in the front. Why did he want to do that? To make it really look like mx plus b, which actually I didn't, right? My 4 minus doesn't look like mx plus. So I think that's a fine way to do it. Yeah. Okay, so I think we can fill in the blanks here. What did we end up deciding? The slope was, what was it? Negative 4/3 is there. The y-intercept was positive 4. And that makes the coordinates 0, 4. Okay, so that's a lot of manipulating with equations. Unfortunately, sometimes there's a bunch of work involved with solving for y. On the next page, let's take a look at a graph. So we can skip over the question itself. I'm just going to highlight that. Find an equation for the graph. That's what we want to do. And we won't worry about the context of this one, but we're just trying to find an equation. Now, in order to find an equation, we know, again, we're using our new favorite formula, this mx plus b. And whenever you want to use that formula, you need to get two pieces of information. You need the slope and you need the y-intercept. Now, one of them is staring at you in this problem. Which one is staring at us? The intercept. So what is the y-intercept here? It's right there. 0, 10,000. Which means that the value of b is 10,000. So we grab that from the picture. But we still need another piece of info. What else do we need? We need the slope. So how do we calculate a slope? Well, we got to do the change in y over change in x. It's something that we did a bunch last class. So you pick any 2 points that are on the graph that you want. So we could use 0, 10,000, and this guy over here, 20, 0, or any other point that's on the graph. I'll use this guy right here. what is that, 4, 8,000? And so remember the slope, change in y over change in x. So we're going to subtract the y's. Over, and then subtract the x's. And then we'll clean it up. This awkward pause is me waiting for somebody to tell me that I did it wrong. What is it, Craig? Craig says 0 minus 4. So Brittany also has a negative answer. It makes sense. What kind of a slope should this line have? It's got to be negative. It's decreasing. But my numbers are all positive here, 2,000 over 4. So that's a nice quick check to make sure you didn't make a mistake. But yeah, if I do 10,000 minus 800 in that order, I am forced to do 0 minus 4 in that order. So let's fix it. 0 minus 4. So the slope is negative 500. And once you have the two pieces of info that we need, it's really easy to just plug back into our purple equation. I'll write it again. Y equals mx plus b. What's the m? Negative 500. We copy the x. What's the b? 10,000. That's it. Questions on getting the equation from a graph? Okay, now we got a little bit lucky in this one because the graph had the y-intercept just right there as some nice number. It was 10,000. But it could be that the y-intercept isn't a nice number. Like maybe the line goes through some random point down there, and I can't look at that and say, well, it's about 8,500. It's just not enough info for me. And instead of being given a picture, we actually might be given 2 points, like here. And just says find the equation of a line that hits those 2 points. Unfortunately, neither of those points is what? Is the y-intercept. So we don't have the slope or the y-intercept given to us in this example. So let's give this a shot. What we need to find first is the slope. So let's find the slope. Okay, so we subtract the y's, 4 minus negative 5, over subtract the x's. All right, so the slope is negative 3. Is that okay? What do we still need to find? The y-intercept, right? We don't have it in this case. We just have 2 arbitrary points here. So here's a technique to find the y-intercept. We're going to use the y equals mx plus b. It's our favorite equation today. We're going to plug in what we know. What did we just find? We just found the slope. That's the m. So I'm going to plug in negative 3 right there. I'm going to put a plus b at the end here because that's the thing we want to find. I've got two blanks where there used to be x and y, right? Now you can plug any point in that's on the line, and it's going to satisfy the equation. So you get to pick either of those 2 points that's circled up there in green. Makes no difference which one you pick. And then we're going to find the y-intercept. I'll pick the first point, -1 and 4. Which one is the y value? It's the 4. So right here, instead of the y, I'm going to put 4. And then over there, instead of the x, what are we putting? It's -1. Everybody see it? It's that first point, -1 and 4. And that's enough info to find the value of b. So we just solve. 4 equals 3 plus b. Subtract 3. And we find b is 1. Okay, to practice that, because it's new for us, some of you might already be quite good at this idea of finding the b, but instead of using the -1, 4, can you guys use 2, -5? I want you to find the b, even though we already know it. I just want us to find it again for practice, and also see that it makes no difference which point you pick. So with your neighbors, can you plug in? We still know the slope is -3, but we're going to use that other point that's highlighted in yellow. Give that a shot, and then we'll come back together. Okay, I got b equals 1. Again, questions on finding the y-intercept? Let me know if you're having any issues with this. We'll fix it now. Yes, Victor. It's not always going to be 1. It's 1 for this particular line. So it's going to be 1 regardless of which point you pick in this case. For different points that you start with, you won't get 1 necessarily, but you'll get exactly the same number regardless of which point you pick. Other questions on this? Okay, we're going to skip a little bit of stuff. Let's jump to the next page here. And at the top is a summary. There's 2 different equations of a line that are in this section. One of them is the one that we worked with exclusively today, y equals mx plus b. There's this other one. Can you guys raise your hand if you've seen this equation right here? Y minus y1 equals m times x minus x1. I just want to get a show of hands. So just a few. Raise your hand if you've seen this one before today, y equals mx plus b. Yeah, it seems like in high schools, it's almost all mx plus b, and that's kind of a shift that's happened in the last, say, 10 years or so. So there's this other equation of a line, y minus y1 equals m times x minus x1. I want to use that equation just one time so that we've seen it in this class. So let's give it a shot. We're going to use that equation right there to try number 10. Can we go to Kyle? Yeah, so have you guys seen, like, on your shoes that there'll be a whole slew of numbers there? Like maybe you wear like a size 10 or whatever, but that's not the only number that's on the shoe, right? And so, like, if you actually just take your shoe off now, probably you'll see a whole collection of numbers because shoe sizes are not standardized across the world. So here's some information that you can get from looking at a few pairs of shoes, that European 37 is an American 5.5, and a European 40 is an 8.5 here. So what I want to do is come up with the relationship. There's some equation that relates the European shoe size to the American shoe size, and it turns out it's a linear equation. So let's give this a shot. So we're going to make a table of values here. So I'm going to make a table with the first column being the American shoe size, and the second column will be the European shoe size. And so for, what do we have here? 5.5 is the American. And what's the corresponding European? 37. And there's another data point given in the problem, so fill in the next row with two other numbers from this problem. So 8.5 here is 40 over there. And if I just put a little x here and a little y there, I can now completely forget about all the stuff in the problem. I can completely ignore the context and just say, oh, this is just 2 points, 5.5 comma 37, 8.5 comma 40. And it's just 2 points. And we know how to find the equation of a line with just 2 points. What's the first thing we need to calculate? The slope. So let's find the slope. So what do we subtract first? Y2 minus Y1. So what are the Y's in this problem? 40 and 37. So subtract the Y's. And on the bottom, subtract the X's. 8.5 minus 5.5. Okay, so upstairs is a 3, downstairs also a 3, altogether 1. So what that means is that there's a one-to-one relationship between European shoe sizes and American shoe sizes. If one shoe size goes up by 5, then the other one also goes up by 5. They just had different starting points. So let's see if we can find the other piece of info that we need. So we've already spent all of today talking about this mx plus b stuff. We're going to try using the other equation right now. So here's the idea with the other equation. I'm going to copy down the y minus. For y1, all you got to do is pick either of the y values. We're just going to pick any point that we have. I'll pick the first one. So instead of y1, I'm going to put a 37. And I'll highlight this first row just so that it's clear what numbers I'm picking for x1 and y1. Equals, okay, the next thing in our equation is an m. We just found the m is 1. 1. Parentheses. I'm going to copy the x. Then there's a minus sign. And then we put a specific x value. But you better put the x that matches up with the y that you picked. So 5.5 goes here. And I'll highlight these two in yellow because they came from that first row. Questions on plugging into that equation? Don't be shy if there are, because from what we saw from the show of hands, people in this room have a lot more experience with the mx plus b version than this other one. Any questions on how we wrote down that equation based on the circled blue one? What's that? We're actually not. Are you asking if we're going to put in the other point? We won't. You'll end up getting an equation that's true if you put in the other point. But what we want to do is just clean up the equation we have. So first thing I'll do is distribute that 1. But multiplying by 1 doesn't change anything, so I'll just write this. And then if I really like this green equation here, I got to solve for y. What's the one step to solve for y? Add the 37. So we add 37 to that. What is that? 31.5? Am I right? And so there's the equation. The European y equals the American x plus 31.5. Yeah, it looks like mx plus b right now. I think I heard somebody asking something. Yes, Mariah. 31.5 is the y-intercept. Yeah, if there were an American shoe size of 0, I have no idea. Do we have a shoe size of 0 here? So an American 0 would correspond to a European 31.5. Yurka. Either one is okay, generally speaking. Like this answer gets full credit, and so does this one. If I want one over the other on a quest or a test, I would have to be explicit. You know, put it in the slope-intercept form, or put it in the point-slope form. I'm curious. I don't see. Yeah, this one just has the American version on it. If anybody feels like taking off your shoe, can you tell us if the European is 31.5 more than the American? What do you have? Who's got both numbers on their shoe? What do you have, Alex?
I got a 12 US and a 46.
I have an 8 and 39.
Other numbers? Anybody else have both?
11, 44.
Okay, all right, so let's see how close our equation is. What do we have to add to 12 to get up to 46? Was that 34? Plus 34? All right, how about here? Plus 31. All right, that's really close to the plus 31.5. What about here? 33.3. Yeah. So what's going on here? I don't know. I don't know much about shoes. It's possible that there isn't even consistency, that there's not one uniform rule. Different companies do size things a little bit differently, right? Like if you're comfortable wearing a 10, then it might not be a 10 across all the different companies that make the shoes. Okay, so group activity is here. I'll continue to check homework and answer questions if there are any, so raise a flag if I can help.